Hi everyone, my name is Mari Carmen and I am translating this tutorial created by Gabriela Carita, which talks about the spectral signatures of different water quality in the ocean. So, in this tutorial we are going to be using satellite images and we are going to be using the semi-automatic classification plugin to identify said spectral signatures. So, first of all, different space agencies have facilitated access to information provided by satellites through servers and websites, where satellite images can be downloaded for the analysis and interpretation of natural resources. For this instance, the quality of seawater can be analyzed through the classification of specific footprints or spectral signatures using geographic information systems tools such as QGIS 3 and the semi-automatic classification plugin. We have downloaded the Sentinel-2 images provided by the European Space Agency, and they have a very good resolution and they are multispectral images. So that means that we have 13 bands and we can download them from the Copernicus Space Hub. And we can download them for free. You can also download these images with the semi-automatic classification plugin. So to install the semi-automatic classification plugin, we have to open QGIS. I am using QGIS 3.0 and I have my project here, so now it is open. We have the satellite images and I have already downloaded the semi-automatic classification plugin. But to do so, we have to go to plugins, then manage and install plugins, and then look for semi-automatic classification plugin. We click on it and then we are going to have this button. It will say install plugin. We click on install plugin and that's all. Then we are going to have this menu toolbar and it's called SCP. We can open the plugin by clicking on Show Plugin, and we are going to be using the dock. If we don't have the dock here, we have to right-click on the toolbar and then click on SCP Dock Panel. So if we click here, then it disappears. If we click on it again, it appears. So here we have the dock, and here we have the layers. We can use the semi-automatic classification plugin to enhance the bands and to make some virtual band sets. So we have to show the plugin, and here we have the band set option, which is the first one. And we have these bands. We have band 2, 3, 4, 5, 6, 7, 8, 11, 12, and 8A. We can add them to the band set. And then we are going to see that here we have the center wavelength. So here we have the wavelength unit, which is the band number. So band 2 will be band 1. For QGIS, the name of the band will be 1. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is very important because we are going to be combining the wavelengths or the bands. So it's important that we know the number of each band. Here in settings, we are going to select Sentinel-2. and the wavelength bands are going to change. And here we have the wavelength units, which is micrometers, and now we can click on run, and we can just save it somewhere. And that's all. Now we can check the number of each band in this column, which we cannot see very well, but here we have 1, 2, 3, 4 until 10. Okay, so if we wanted to show a different combination, we can go to this part of the SCP plugin, and here we have select a RGB color composite. And here we have the 3, 2, 1. If we want to change the color, we change the numbers. So 3 to 1 is a natural color set. And if we want to change it to a false color to enhance water bodies, we will use the bands 8, 11, and 4. And those are sentinel bands. But here, bands 11, 8, and 4, 11 is number 9, 8 is 7, and 4 is 3. So we can make different combinations. We are going to do 7, 9, and 3. And we're going to get this image. Or we can do another combination, which is 7, 3, and 2. And this is the false color one, the infrared one. And now we can see that there's a difference between these two parts of the ocean. The red areas represent high concentration of vegetation. In this image, we are observing the Mar Menor, or Minor Sea, and the Mediterranean Sea. In the inside, here in this part, we can see if we had a natural color image, that this part of the ocean is greener than this side, and that means that eutrophization has happened here. And now we're going to go again to the false color image, and we are going to compare the spectral signatures of each side of the ocean. Before this tutorial, we have classified the Mediterranean Sea and the Minor Sea to check the spectral signature. Now we're going to see the behavior, and we're going to open the spectral signatures. To do so, we're going to the SCP doc and then go to the training input. Here in the training input, we are going to open a training input. You can download this training input and the images from the article of Hatari Labs. And you're going to have a folder called training, and here we have the training input. So we're going to click on them, and here we have Mar Mediterráneo, which is the Mediterranean Sea, and Mar Menor, which is the Minor Sea. And now we can click on this symbol, which is Add Highlighted Signatures to Spectral Signature Plot. And in this case we don't have any because we didn't highlight them. So if we select them, then we're going to have two spectral signatures. In this case we have the blue one for the Mediterranean Sea and the yellow one for the Minor Sea or Mar Menor. And here we can see that the Mediterranean Sea hasn't been affected by the eutrophisation process, which means that there's a higher concentration of plants and nutrients in the ocean, and it happened in the Minor Sea. So here in the Mediterranean Sea, we can see that the ocean tends to absorb most of the light. So we can see that the values of reflectance are lower than the Minor Sea. The green wavelength is not significant, and it disappears when it gets closer to the infrared zone. So the green region is right here, and we can see that there is no high reflectance for the Mediterranean Sea. And we can see that the reflectance is low in the infrared region as well. In contrast, for the Minor Sea, we can see that the reflectance of the green region is higher than the Mediterranean Sea, and we can see also that it has a spectral signature very similar to the vegetation one. So here we have a higher reflectance in the green region, and then we have a very, very low reflectance in the infrared region. And this has a higher reflectance in the green zone due to a higher concentration of chlorophyll. And this is the result of the high nutrient concentration that the human activities are adding to the ocean. So this is how we can compare spectral signatures of different water bodies. And we can see that each water body has its own spectral signature, and we can compare it and see which processes are affecting the spectral behavior. I hope this tutorial helped you, and I hope to see you in the next one. Please, if you like it, share it, and if you have some doubts, comment this video. I'll see you in the next tutorial. Thank you.